Welcome to lesson number 8. We're still investigating the graphs of polynomial functions. Now, with this lesson, again, it'll be like lesson 7. It's going to go pretty quick, but it's going to be a little different. I'm going to introduce you to a new term called multiplicity. So you may not have heard of this before, but this is just going to correspond to an exponent, and this exponent means that we have a factor that shows up more than once. Now let's look at an example. Now here I have the graph of the polynomial function, and this polynomial function is x plus 1 times x minus 3 squared. All right, so notice this squared here. That means that what I have is x plus 1 times x minus 3 times x minus 3. So the polynomial, but still I only actually have two factors, and those are x plus 1 and x minus 3. X minus 3 is repeated, and this also means that I only have 2 zeros, not 3 zeros like we might think. So the factors are, again, x minus 3 and x plus 1. X minus 3 is the one that's repeated, and since it's repeated, I only have two factors. I have -1 and I have +3. So we would say that this graph has two different x-intercepts, not 3, and we say that it has two real distinct zeros. Right, -1 and +3. But the x-intercept represents what we call a real zero, and the x-intercept over at +3, this represents two real zeros, and they're equal. So they're both equal to +3. Now, in this case, where I have a repeated zero of 3, that means that my zero has a multiplicity of 2. Multiplicity of 2, where the 0 was -1, there was only the 1 0 there, so that had a multiplicity of 1. So what the multiplicity is it corresponds to how many times that a factor is being repeated. So in this case, x minus 3 was repeated twice, and so that's where we had a multiplicity of 2. If we had x minus 4, x minus 4, x minus 4, this would equal x minus 4 cubed, and this would also be, this would have a multiplicity of 3. All right, now when we're looking at these types of examples, we're going to notice that there's a few different characteristics of these types of functions. So the first one is a tangent that forms. A tangent is when our graph just touches the x-axis but doesn't cross it, right? So both of these are examples of a tangent line. It's touching our x-axis, but it's not actually crossing it. Next, we have a point of inflection. Now, a point of inflection occurs when we have a change of concavity. So in this case, we have our graph is going concave up, and down below it's going concave down. Sorry, that's my oven that's preheating. Next, let's look at this function. So I have p of x, and that's equal to x to the power of 6 minus x to the power of 5 minus 11x to the power of 4 plus 13x cubed plus 26x squared minus 20x minus 24. And I could also state this as x plus 3 times x plus 1 squared times x minus 2 cubed. So with this zero, I would have a multiplicity of 2, and with this one I'd have a multiplicity of 3. Now the first thing we want to do is sketch this graph, and we want to sketch it according to our window settings of -5, 5, and 1, and -100, 120. Now I really recommend using brackets here just to make sure that everything in all your functions are separated. X to the power of 6 minus x to the power of 5 minus 11 x to the power of 4 plus 13 x cubed plus 26 x squared minus 20x minus 24. And then I'll graph that. All right, and so notice all these different characteristics of our graph. So here I just have it passing through the x-axis, crossing the x-axis. Right here it's forming a tangent to our graph. And over here we have a change of concavity. We're going concave down and then going concave up. All right, so that's happening at 1, 2, 3 different zeros. And we already know what our zeros are. We have -3, we have -1, and we have +2. Now what we want to do here is state what's actually happening at each of these multiplicities. So -3, that had a multiplicity of 1 because there's no exponent shown and there's only one set of that zeros. -1 has a multiplicity of 2 because there's 2 x plus 1 to the power of 2, which means it's x plus 1 times x plus 1. Then x minus 2 had a multiplicity of 3. So if I were to graph this, it's going to look something like this. And if I have a graph that looks like this, this was at -3. That's where I had x -3. This is where x was -1, and this is where x was +2. Now at -3, where my 0 was -3 and I had a multiplicity of 1, that just passed through the x-axis. Where I had a 0, -2, and a multiplicity of 2, notice that it's tangent. It formed a tangent to the line, to the x-axis. And finally, where my multiplicity was 3, that's my point of inflection, where it goes concave up and then concave down. So the degree of this polynomial is going to have a degree of 6. And here, if you notice one thing, if I take the sum of my multiplicities of the zeros, and so we're looking at the multiplicities 1, 2, and 3, those are going to add up to give us 6. Okay, so the sum of the multiplicities of the zeros of p of x is going to equal 6. So I added 1, 2, and 3 to give us 6, and that equals the degree of the polynomial. The next thing we want to do is use technology to the nearest tenth to determine the value of the function. Alright, so to the nearest tenth, we want to find out the value of this function. And we'll just go 1, x equals, and we'll just skip this part for now. Now this next example it's pretty self-explanatory. All you're going to do is plug in this function according to these window settings, and then set your multiplicities. So your first 0 that we're going to have here, well, actually I'll have to graph it out, but this is probably something that you can do yourself. You can graph this according to these zeros and then find out where your zeros are. So where does the line cross the x-axis? And then according to each multiplicity, what is going to be happening at each point. All right.